Hey guys, welcome to my video 3 for the project. This is the last video for the project 1. There are 4 parts to this video. It is divided into demonstrate, interconnection, and the demonstration of timing wireless data transmission. The next is the equipment data change process display into the web page, and the conclusion of the whole project. In this wireless connection, I need to use 2 software to help me with networking transmission. TiVNC is a cross-platform remote desktop software application. It uses and extends the RFB protocol of the virtual network computing to allow the end user to control another computer's screen remotely. With this software, I can control the Raspberry Pi on my Windows PC. My Raspberry Pi is already connected to the Wi-Fi in my house. PuTTY can also be used to connect to the Raspberry, but it's not as easy to operate as TiVNC. Next software is the FreeSSHD. FreeSSHD, like its name says, is a free implementation of non-SSH server. It provides strong encryption and authentication over insecure network like internet. Users can open the remote console or even access their remote file thanks to built-in SFTP server. It used SFTP server, which allowed my PC to wirelessly encrypt file with the Raspberry Pi. The file I need will be sent from the Raspberry Pi to the designated location on my PC. Okay, let's start the demonstration. I need to connect the Raspberry Pi first. I've already entered the IP address of my Raspberry Pi in here. Click connection and enter my password. Okay, I'm in the desktop of the Raspberry Pi 3. Let's take a look at the file what I will using later. This Python file is used to gather data from the Arduino board and save it to the specified file path in the Raspberry Pi 3. I will show you the detail of the code a little bit later. The next one is an upload code. This code is in Paramiko. Paramiko is a Python implementation of SSH protocol, providing both client and the server functionality. When we run it, it will automatically connect its Raspberry Pi with my PC via SFTP. Before I do that, I have to enter my PC's IP address, port, and so on into the code. The next is shell file for upload data. It will run those 2 codes I just described. And I can set a timer to run this shell file. Let's open the Raspberry to Arduino.Python. I'll mention a few important parts about this code. The first is that a set of the connection port for the Raspberry Pi to connect the Arduino board. The Raspberry Pi will send an S to the Arduino board, which means the Arduino board can start work. The next one is to read data which sent back from the Arduino board and then correctly save it to the specified file. So the next code is the upload the Python code. we need to import Paramiko and enter the remote server information, connect the server, and then SFTP upload the information to the remote server, which is my PC. This is to pull the Raspberry Pi file into the specified folder in my PC. Then is the shell file. Run those two Python files. The following is to set up the shell file to run on time. Enter this command, then enter this call. I will set it to run the shell file once a minute. Let's look at the folder where the sensor data is stored. Open the upload folder. We can see the data from different sensors are sorted into different text files. I will try to run in the shell file next and see what happens. We can see that my PC's SSH is not connected. I don't think it can be connected. Yeah, let's see what the problem it is. Unable connect to the IP address and timeout. Okay, I'm connection the SSH now. Okay, the SSH has been connected already. Next, I will check whether the file uploaded from the Raspberry Pi, but SFTP will be put into the specified folder correctly, and whether the data are consistent. First, we will open the data file of Raspberry Pi. On the PC, the folder is empty. The file should be uploaded soon. Okay, here we go. Let's open the temp-C and check. Both data are the same. Let's see if the other data are the same as well. Oh good, all data are the same. The next step is to view the data on the web. Open the web page with the Internet Explorer. Then click Yes. Okay, the data is already on the page and it matches the data in the file. After half an hour of waiting, the line chart are longer and are all live data. You can move the mouse to view the data at any point and the corresponding time. We can easily to see the change of the data through the dynamic trend of the line. In order to ensure the data is correct, let's compare the data of the web page and the data in the text file. Celsius 18.58, right. Fahrenheit 65.44, that's right. The way, because I didn't put anything on the scale, so it's 0. It's right. And what level? 393. It's correct. Let me show you my HTML code, which took me quite a while because I don't have the experience to write this kind of code. Spend a lot of time on on the internet for researching. This is the file path, and this is the file path of the way. My project 1, which lasted for 95 days, has now completed 90% of all the project. The remaining 10% is to complete the report or finish it before the deadline. The whole project is divided into 3 main parts. First is select the project. Second, build the simulation equipment. And the third, upload the data. Here are the 3 most time-consuming parts. First is the code and the debugging. The second, the collection and the purchase of necessary electronic components. And the third, the conception of the project. The systems have been using this project is Windows and Linux. 2 main hardware, the microcontroller board, Arduino Uno board, and a single board computer, Raspberry Pi 3B. 2 software is Type VNC and FreeSSH-D. Programming statements are using C language, Python, and JavaScript. Alright, so that's the end of my video 3, and then this is the last video. Hope to see you next time. Thanks for watching.